Katherine Falk, and co-director of the UNC Kidney Center. He's also a staff nephrologist at the Salisbury VA Medical Center. After graduating from the Armed Forces Medical College in India, he trained in internal medicine and nephrology at the University of Aberdeen in Scotland and at the Beth Israel Hospital with Harvard in Boston. In addition to being an active transplant nephrologist, his main area of research is in uremic vascular biology, including both dialysis vascular access dysfunction and cardiovascular complications in patients living with kidney disease. He's been the recipient of extensive NIH, VA, and industry research grant funding and has published over 250 manuscripts, book chapters, and has delivered over 400 lectures across the globe. So we are very excited to have him here today. He's also actively involved in public policy and administrative aspects of dialysis vascular access care and hemodialysis through leadership roles in multiple societies and is the current president of the American Society of Nephrology, the largest professional kidney organization in the world with over 21,000 members. He's also the founding ASN co-chair of the Kidney Health Initiative, a public-private partnership between ASN and the US FDA, and is a current member of the FDA's Cardiovascular and Renal Drugs Advisory Committee. Thank you for being here, Dr. Roy-Chaudhury.
Wonderful. Thank you so much, Annie and Vandana and Dr. Del Rio for this invitation. I just want to confirm that you can see me and hear me. I'm going to take that as a yes. So delighted to be here at Emory. And what I'm going to speak to you about is really, I think, a new area. And it's really going to be about the changes that are currently taking place in kidney disease. And I'm obviously biased, but I think are just incredibly exciting and important. So these are my disclosures. And what I am going to do in this presentation is really, in a way, talk about two main things. I want to initially describe the innovation and the change and the excitement. And I think very importantly, the hope, because that's a very important word for patients, that is transforming the traditional fabric, if you will. Let me just move this a bit down. Sorry. That's transforming the traditional fabric of kidney care. But I think even more importantly, I want to weave through this fabric of innovation and hope a very strong thread of education and awareness and equity and access to care and policy, which are really the true engines of change. And obviously, Dr. Del Rio has been so involved, particularly, I would say, in the policy aspects of change. I'm going to use two examples from the kidney world, chronic kidney disease and hemodialysis, to make my case. But the first thing that I want to say is that when you think about curing kidney disease, is it ambitious? Yes. Is it audacious? Yes. But is it possible? And that's the most important one. And I actually think that at this point in care, or at least in the future, that is possible, which means that all of us will be out of a job, but that's okay. So let's talk a little bit more about chronic kidney disease. So it's common. 850 million people worldwide have chronic kidney disease. That's about 1 in 7 patients. There are 37 million people in the United States with kidney diseases. It's the 8th leading cause of death in the US. 9 out of 10 US adults who have kidney disease actually don't know that they have it. And we spend a lot of money on chronic kidney disease. At last count, over $130 billion. And of that, $50 billion is really for kidney failure alone. I think, as is well known to most of you, the main causes of chronic kidney disease are diabetes and hypertension and glomerulonephritis. But what is also important are two additional points. The first is that there is, for most types of chronic kidney disease, a final common pathway of fibrosis. And that's important when we speak about new therapies in a bit. The second very important point, and I think I alluded to it already, is that it's a global problem that is growing. And I want to focus in my next slide a little bit more on this last point. About 30 years ago, when I started off in nephrology, and there's a story there which I will tell you. Chronic kidney disease was the 18th most important cause of death globally, right? So this is not US data, this is global data. And in 2019, it had increased to the ninth most important cause of death. The top right panel, and let me try and get my pointer back. The top right panel is really important. This is from a paper that's over 20 years old. And what it shows is that as your GFR decreases, so too does your risk of cardiovascular disease increase, and it actually increases exponentially. That's a really important point, not just in the context of the new therapies that I'm going to tell you about, but because a lot of the morbidity and mortality that comes from chronic kidney disease is linked to cardiovascular disease. And so if you then look at the bottom right panel, the burden of kidney disease across the globe is huge. People die early, people have a poor quality of life, it costs a lot. And one of the things that I think is very personal for me as I see patients or have seen patients over the years is that chronic kidney disease, and particularly dialysis, doesn't just impact the patient, it actually impacts everybody around the patient's family as well. So I want to go back a little bit and just emphasize on the 30 years. And I say that with a smile because I started off in nephrology 30 years ago. So in 90, and so I'm old. In 1993, I was a young nephrology fellow at the Beth Israel Hospital. And I remember I was on a T in Boston going to work, and I was reading the New England Journal of Medicine paper by Ed Lewis, which showed that if you take captopril and you use captopril in patients with chronic kidney disease, that the rate of progression of kidney disease decreases. And there was a very sort of renal mechanism, afferent, efferent, arterial there. And I remember thinking, as a young nephrologist, this is so great, right? We now have a drug that is a kidney drug. And I just expected that new therapies would keep coming out one after the other. But the reality, unfortunately, was a 25-year drought. The only new drug really was a cousin of ACE inhibitors, which were angiotensin receptor blockers, so the telmisartans, olmesartans, losartans. And it was not a great time for kidney disease, but because I hadn't known any different, I actually didn't realize what I was missing. And then the kidney world changed completely in 2019 with a study that showed that if you use SGLT2 inhibitors in patients with diabetes and chronic kidney disease, that you actually were able to make an impact in reducing the progression of chronic kidney disease. And since then, we've had a flood of new therapies that have come into the chronic kidney disease space that also, very importantly, have cardiovascular benefits. And as I'll show you in a moment, we also have a number of upstream therapies that target the glomerulonephritis. What is important, I think, is that we are really at an inflection point in kidney care. And for all the nephrologists in the audience and for everyone else in the audience, it's really important that we grasp this moment in time, that we ride this wave, because our patients cannot go through another 25 years of therapeutic stagnation. I think that's a really, really important point. Now, when you talk about new therapies for chronic kidney disease, particularly progressive diabetic kidney disease, which is the big 800-pound gorilla in the room, you have to talk about different mechanisms. And I really want to recognize Dr. Bakris, who unfortunately, he was a professor at the University of Chicago. He was a friend, he was a colleague. Unfortunately, died well before his time last year, but George had this unique ability of taking very complex concepts and simplifying them. And George's sort of approach to progressive diabetic kidney disease, and to a very great extent, chronic kidney disease, was that there are three interacting pathways: hemodynamic perturbations, inflammation, and metabolic dysregulation. And the reason that this is so important is that at this point in time, we now actually have therapies that can target all three of these mechanistic pathways. So we obviously have ACEs and ARBs, and they primarily tackle the hemodynamic perturbations, the hyperfiltration, the glomerulosclerosis that occurs when you have diabetic kidney disease, or really also chronic kidney disease. But in addition, we now have the SGLT2 inhibitors that target both the hemodynamic and the inflammatory pathways. We have a non-steroidal mineralocorticoid receptor antagonist called finerenone that targets the inflammatory pathway. And then we also have the Ozempics, the GLP-1 receptor antagonists that target metabolic dysregulation. And so as a result of these new therapies that I'm going to speak about, I think that the chronic kidney disease world has changed. So just a quick overview of the new therapies. I spoke about the Credence study, but what's important to note is that there have now been 3 very large randomized pivotal clinical trials which clearly demonstrate that regardless of whether you use canagliflozin or dapagliflozin or empagliflozin, all of these drugs are effective when given to patients with chronic kidney disease, either as a result of diabetes or not as a result of diabetes, that they improve a composite kidney and cardiac endpoint, and they do this across a range of eGFRs, as long as you're over 20 to 25, and as long as you have at least a little bit of protein in the urine, so a UACR of greater than 30 in most cases. So that's SGLT2s have a beneficial effect on heart problems and kidney problems in patients with chronic kidney disease, right? So very important if you remember that top right figure earlier, which said that as your GFR goes down, your risk of cardiovascular problems goes up. And then you have a second class of drugs, sort of the successor to spironolactone, if you will, finerenone, which is a non-steroidal mineralocorticoid receptor antagonist. And the bottom line to remember for finerenone is that if you use finerenone in the setting of patients with diabetes and chronic kidney disease with some proteinuria, that you reduce the composite cardiovascular outcome by 14%, the composite kidney outcome by 27%. So again, drug number 2 or drug number 3, if you do ACE/ARB, SGLT2, and now non-steroidal MRA. And then finally, in May of last year, really a groundbreaking study for us in the kidney world, which showed that if you use the GLP-1 agonist in patients with type 2 diabetes and chronic kidney disease, that once again, you reduce the kidney endpoint by about 25% and the cardiac endpoint by 30%. And in just a couple of months ago, FDA approved Ozempic for the treatment of chronic kidney disease in patients with diabetes. And so now nephrology has gone from those 25 years of therapeutic stagnation that really defined the major part of my professional career to a place where we have a new sort of problem. Right now, our problem is, how do we use these drugs in diabetic kidney disease and chronic kidney disease? Do we have a tiered approach where we use them over a period of time, 6 months, over a year, over 2 years, depending on what happens to the proteinuria and the creatinine? Or should we use them in a pillared approach where we say that because these drugs act on different pathways, we should do exactly what my son actually tells me, who's a cardiology fellow, tells me that I should be doing, which is put them all together. And he may actually be right for once only. So should we use them all together in terms of a pillared approach, obviously? And what I will say, and this is why he may be right, is that some of the simulation data that has come out actually demonstrates that when you use these new drugs in combination in the group of patients that I described, that you actually get an additive effect, both with regard to cardiovascular outcomes, as shown on this slide, and with regard to CKD progression. And again, if you go back to that young nephrology fellow in 1993, who had really high hopes for the future, which I think now, 25 years later, coming to fruition. I mean, reducing a composite of kidney progression by 58%, sort of unheard of. This is a simulation, but the studies using them together are beginning to be done. And the big thing, of course, about these therapies, and I just want to come out and say this straight off, and this was the discussion with Dr. Del Rio before we started this meeting, was that perhaps if we were able to use all of these new therapies together, and there are two more actually waiting in the wings, that we may be able to prevent people from needing dialysis. And wouldn't that be absolutely wonderful? And so there is, I think, emerging a new paradigm for cardio-kidney-metabolic care. And that paradigm, of course, is, and the AHA has, I think, done amazing work in this area. But the new paradigm is that people don't just get kidney disease on their own. The people who have kidney disease also have heart disease, they have diabetes, and they have obesity in most cases. So that's why you have this emphasis on cardio-kidney-metabolic care. And so what we could do, whether as nephrologists or cardiologists or endocrinologists or primary care physicians, is that we could surround these patients with these four pillars of therapy: ACE/ARB, GLP-1, non-steroidal MRA, and SGLT2 inhibitors. And again, I think the data about the exact way to use them together, I think, still needs to come in. So I'm putting out there this new paradigm for the future. But I do think that a lot of the data suggests that this is the direction that we're going to be going in for probably a substantial minority or majority of patients. But then, and this is really important for all of you, because you are the people who are going to use these drugs, there is a third outer circle. And that third outer circle is made up of things like access to care and equity and policy and quality. So that third outer circle is all about implementation. And I want to focus a little bit on equity and on access to care. And again, it's important to tell stories. So the next story, so the story I'm going to tell is really a story about Martin Luther King, actually. And what Martin Luther King said in 1966, so well over 50 years ago, was that of all the forms of inequality, injustice in healthcare is the most shocking and the most inhumane. And I just want you all to look at the middle slide. So I'm a nephrologist, and the middle slide describes to you the number of people globally who are on kidney replacement therapy. And so if you look at the blue, you could see that in 2020, there were over 3 million people who were receiving kidney replacement therapy. And you could look at it, and as a nephrologist, you could say, wow, that's great, and look at the number that's increasing. But the real number, right, the number that's important is that in that same year, there were at least 8 million people who died across the globe. And this number is almost certainly a huge, actually, underestimate. But these people died because of a lack of access to dialysis or kidney replacement therapy care, mainly because of cost. And so I think the important message for these new therapies is that we have to do better with these new therapies with regard to implementation. And I also want to share with you that the maximum impact of these new therapies could be in parts of the world or in parts of this country as well, rural areas, inner city areas, areas with poor access to care, where there's limited access to both chronic kidney disease care and to dialysis. And I would say that we actually have the opportunity to be able to do this globally and nationally, because there's still issues in this country about people getting these drugs, but these drugs will soon be generic. And the cost of a year's treatment with dapagliflozin, for example, will be 20 to 100 times less in different parts of the world than the cost of dialysis. So again, I think these therapies have a much larger impact than just a much larger global. There's a potential for a very big global impact. So let's talk a little bit more about implementation, right, across the globe. And there are all of these barriers, obviously, to the equitable use of new therapies. There's a great paper that's referenced there that, again, looks at these things globally. But I just want to highlight a few of the barriers. Uh, Patient self-care and patient empowerment, right? That's important in whatever sort of disease you're talking about. But then on the clinician side, guideline overload. I chose that because we have a lot of guidelines, and if we have time, I'd love to have a discussion on this. And uh, I think that if we have too many guidelines, you end up implementing nothing at all. And so, I think we really need to work together in terms of guidelines. And so I think, organizations like ASN and AHA and other organizations in the cardio-kidney-metabolic world working together to develop one set of guidelines, I think is actually really important. We've spoken about poverty. That's really important across all aspects of kidney disease and across all aspects of implementation. Care fragmentation. There are lots of people involved in the care of these cardio-kidney-metabolic patients, in the care of kidney patients that often doesn't help. Lack of public awareness. We'll speak about this in a moment. And then I would say that globally, we have focused in nephrology on dialysis and transplantation. I think that now that we have these new therapies, we need to switch gears and focus on prevention. I will also say, and this is important, that it's not just in cardio-kidney metabolic disease that things are changing. There are a whole host of rare diseases in the kidney world, mainly the glomerulonephritis, IgA nephropathy, membranous nephropathy, lupus nephritis, where focal and segmental glomerulosclerosis, where the model that I described to you earlier about identification of mechanisms, as shown here for IgA, and then translating these into new therapies is happening. Three new therapies just in the last 5 years for IgA nephropathy, a host of additional new therapies targeting different mechanistic pathways in clinical trials. And again, for IgA nephropathy, for those 25 initial years of my career, there were no real therapies other than ACEs and ARBs. We're now approaching a precision medicine-based approach where it's a good question for us, or the problem is, which drug do I use first, second, and third? And again, similar to cardio-kidney-metabolic disease, should I use all of them together in a number of patients, in some patients? And that's why nephrology, I think, for all of you as residents, currently could be such a great opportunity, because you want to come into a new specialty when things are changing, so that all of you can actually be a part of the change. And that's really the biggest message I'd like to put out. Wearing my American Society of Nephrology hat, this is a time of excitement and change for kidney diseases. Again, another story, right? Stories are always important. So if you look at this slide, you would think, well, this is classic bedside to bench to bedside. You had a clinical problem, you identified mechanisms, you developed new therapies for that targeted those mechanisms. But the truth is actually a little bit different, and regulation comes into the truth. So for for the last 30 years, 25 years, really, there were really no new innovations and no real therapy for IgA nephropathy, which is the commonest form of glomerulonephritis in kidney diseases. And the main reason was that it was very complex and very costly to do clinical trials because the FDA said that the endpoint to determine that a new therapy was effective in the kidney disease space for IgA nephropathy was that you had to demonstrate an impact on an endpoint of the 3Ds: death, dialysis, and doubling of serum creatinine, which meant actually that a clinical trial for IgA nephropathy could go on for 5 to 10 years. And what happened was that when you had big pharma with a new molecule that perhaps could have worked in IgA nephropathy, but could also work in, let's say, inflammatory bowel disease, they went down the inflammatory bowel disease or the rheumatology pathway because it was too costly and too complex to do clinical trials in the kidney world. But all of that changed through a Kidney Health Initiative project. I'll speak a little bit more about the Kidney Health Initiative, but this is really a public-private partnership between the American Society of Nephrology and the FDA. So the kidney community worked together with the FDA to look at all of the available data, and they were able to demonstrate together that if you looked at the change in proteinuria 9 months after starting a new therapy for IgA nephropathy, and if there was a significant change in proteinuria, that all the available data over the last 30 years showed that that would translate into a decrease in death, dialysis, and doubling of serum creatinine, if you will. And so now, instead of organizing a study that had to go for 5 years, the FDA said, use the accelerated pathway, demonstrate a benefit at 9 months in proteinuria. We'll allow you to sell the drug while continuing to obviously follow these patients. And that's the reason why I think we have these new therapies that have not only been shown to reach the surrogate endpoint, but a number of them have now also been shown to reach the harder endpoint of death doubling and death doubling of serum creatinine and dialysis. So again, yes, lots of excitement about new mechanisms, but please remember that process of care and the regulatory pathways are important. And then the last slide in this section of my presentation is that I think this is a huge opportunity for nephrology. So I'm wearing my ASN hat now because I think that these new therapies are going to allow us to break out of our small, relatively comfortable, and unfortunately dialysis-dominated bubble that I think we've lived in for the last couple of decades. And these new therapies are going to allow us to play in a much larger and much more impactful playing field where we're going to be able to prevent people from developing kidney failure, where we're going to be able to prevent people from having cardiovascular problems. And I think that this is going to allow us to demonstrate the value of nephrology and nephrologists to healthcare systems and insurers and payers. So again, yet another reason to come in at the ground level at this time of change in kidney care. So now I'm going to switch gears, and in the next sort of 15 minutes, I'm going to go from preventing chronic kidney disease to trying to see whether we can actually do better with regard to dialysis. So I'm going to go absolutely to the other end of the spectrum. I'm going to start off by saying that at this point in time, we provide really poor value in dialysis care. And I say that we provide poor value because we have really bad outcomes. So if you put 100 patients onto hemodialysis in this country at the end of 5 years, only 41 are alive. And that is worse than almost every form of cancer other than some types of lung and brain and hepatobiliary cancer. And in order to achieve these really dismal results, we spend a lot of money. And this slide is outdated. I have 34 billion over here. It's actually 50 billion already. And I am going to submit to all of you that one of the reasons, not the only reason, but one of the reasons that we provide relatively poor value in nephrology is that we haven't had a huge amount of change in dialysis technology. So if you look at the slide on the left, that's a patient dialyzing at the Royal Free Hospital in 1965. And then if you look to the panel on the right, you see a patient dialyzing actually 2015. So it's already about 10 years ago, but not a huge amount has changed in 6 of those 10 years, I'm going to say. But the bottom line is that yes, there are more bells and whistles in this machine. Yes, there is some miniaturization, but the basic construct of dialysis hadn't really changed over the last 50 years. Now, I want you to keep this picture in your mind's eye as I show you the next picture, which is what has happened in another technology-rich area of life, I guess, and that's computing. And I would guarantee to you that any of these little devices in the right panel, which all of you have in your hands, and I hope you're not looking at them, but are actually looking at me in this presentation, but any of those little cell phones would really have more computing power than this large IBM computer. And so the question is, how can we change dialysis care? Again, I think history is important and stories are important. So I want to start off in terms of the history, really, paying tribute to Dr. Kolff. This is the man who really invented dialysis. He did this in 1944 in the middle of the Second World War, and the first dialysis machine, the Kolff rotating dialyzer, is shown here. And what he basically did was he took a rotating drum, shown in brown, he wrapped sausage skin around it, he rotated the drum in a bath that had an isotonic solution, and he took blood from a patient and ran it through the sausage skins. So the sausage skins acted as a semi-permeable membrane. Now, there are two really important messages on this slide, which really perhaps have nothing to do with medicine, but they're still really important stories. So the first is, if you look at this panel, in the middle, it shows you the blood urea of a patient, and it peaked at 396. So that's a BUN of about 200. And this is the woman shown over here who got the first dialysis, and you can see it, the BUN came down all the way to 60, and then her kidneys recovered. She was in a uremic coma at this point, and she lived. The really important message from this slide is that this was patient 17. So 16 patients had died with Kolff trying to treat them with his rotating drum dialyzer. Persistence is really important. The 17th patient lived. The second really important message, which is also not about medicine, is that after the Second World War, Kolff sent his rotating drum kidneys, one each, to Canada, the UK, the US, and Poland. And if I had been in person, I would have asked you, why did he choose these 4 countries? But the answer is that these are all countries whose soldiers actually liberated the Netherlands from Nazi Germany at the end of the Second World War. I think he was a great man for both of the, he was persistent and he wanted to help the world, really. Now, I will say that in the initial years of dialysis, there was this huge issue about who should get dialysis. And as we move towards, I think, what will be a new era in kidney disease, I think it's really important for us also to understand, what happened in the 60s, because even though I've been critical of dialysis, I will say I'm proud as a nephrologist to own the only form of long-term replacement therapy in terms of a device that actually works. So in the 1960s, dialysis was in scarce supply, and I put up a picture of my cousin Arun because he was the one who helped me take a very long CBS documentary from the 1960s, and he spliced it and split it as only teenagers can. And I want to run that. I want to run about 2.5 to 3 minutes of video for you because I think it's really important.
Nothing can work. The heart can't work, the brain can't work, the lungs can't work. Nothing can work effectively unless the kidneys regulate the intricate chemistry of the internal medium of the body. Prior to 1960, it was not even considered possible to treat patients who would not recover their kidney function. In other words, patients with chronic kidney disease were all doomed to death.
When first invited to serve on the committee, I was very uncomfortable feeling that I was taking the place of God.
Financially, we couldn't afford it. I supposed that I would just die, but I would trust God and pray that I wouldn't die.
The doctor said that I had approximately 2 months to live.
My strongest feeling is that this kind of a committee should not have to exist.
This is going to cost and run into an awful lot of money, maybe billions of dollars. Where are we going to get the money? That's what some of the taxpayers ask us.
It's bad business in more ways than one to let people die. It's good business in plain dollars and cents to keep productive individuals alive today.
Step number 4, the last step in the screening process. The applicant must be approved by a jury of his peers. These are volunteers, anonymous volunteers, who will give the final yes or no to the applicant based on his medical report, his psychological report, his financial report, and on his record as a member of this community, on his record as a responsible human being. In a word, is he worth saving? For the cold, hard fact of the matter is, there are just so many places available on the kidney machine, and there are more applicants than places. Somebody has got to be left out, and somebody has got to decide who shall live and who shall die.
So we've come a long way since the 1960s. The death panels are long gone. Hemodialysis, as I said, is now routine. There are 550,000 patients on hemodialysis in the US, and dialysis remains the only reliable and long-term form of organ replacement therapy. I will say, though, that for most of the world, however, the ability to pay still remains a very important predictor of who will or will not receive end-stage kidney disease therapy. And one thing I want to add, and I always sort of am humbled in many ways by when I listen to that piece, but our problems remain the same, because you could really take those comments and to some extent even apply them to healthcare at the present time. But let's focus on dialysis. So we've come a long way since the 1960s. But I do think that when we talk about dialysis, we have forgotten something that Willem Kolff, a remarkable man, actually had brought out many decades ago. Because what Dr. Kolff had said was that if the treatment of chronic uremia cannot fully rehabilitate people, then that treatment is inadequate. And if you speak to patients on dialysis, they'll use different terms. So basically what they will tell you, every one of them almost, is that dialysis keeps you alive, but dialysis does not allow you to live. So how do we change this, right? How do we make dialysis better so that it allows patients to do the things that they want to do? And this brings me back again to the Kidney Health Initiative and back again to the power of, I would say, multidisciplinary organizations or initiatives. So once again, the KHI was a public-private partnership between the American Society of Nephrology and the FDA. And it was started in 2012, and it was really the brainchild. And again, it's a small world because Dr. Del Rio actually knows Dr. Falk, but it was really the brainchild of Dr. Ronald Falk, who has my chair of medicine and also my mentor. And over here, you see him with Dr. Margaret Hamburg, who was the then chair or the commissioner of the FDA. And you can see I had a lot more hair at that time, which was about 12 years ago. But basically, the goal of the Kidney Health Initiative was to create an innovation substrate, if you will, that would allow new therapies to come into the kidney space. And the way that we wanted to do this, and it was a huge honor for me to be the initial ASN co-chair of the Kidney Health Initiative. The way that we wanted to do this was to get the community together. So healthcare professional organizations, industry partners, patient organizations, federal agencies, not just the FDA, but NIH and CDC and CMS. We wanted to create a meeting place where all of these wonderful, smart, creative people from different stakeholder groups could come together. And our goal was to do projects. And our hope was that the output from these projects, whether they be roadmaps or workshops or surrogate endpoints for clinical trials in kidney disease, would actually facilitate the passage of new drugs, devices, and biologics into the kidney space. And one of the projects that we did was a project on creating a roadmap for new and innovative forms of kidney replacement therapy or dialysis. And our goal was, in this roadmap, which described in great detail a technical plan to go from enhanced dialysis to portable or wearable dialysis to an implantable kidney, and finally to a complete regeneration of the kidney. And xenotransplant was probably at that time in between these two. What was really important about our roadmap, and which is why I think was different from many other roadmaps, is that at that point in time, and even now, this is a living, breathing roadmap. We keep updating it. Even now, we don't know what that final form of future dialysis will be. But what we do know is that whatever that future form of kidney replacement therapy, I'm not going to call it dialysis, so innovative kidney replacement therapy will be, we know that it has to improve the ability of patients to work and travel. It has to result in increased mobility and physical activity. It should not wash patients out after dialysis for the next 24 hours. It has to liberalize patients' diet. It has to reduce their medication burden. It has to reduce hospitalizations and interventions. And very, very importantly, it has to reduce the financial impact on the patient because, again, there's no question at all, regardless of which country in the world you're in, rich or poor, all chronic diseases drive people into poverty. And unfortunately, my sense is that kidney disease perhaps does this better than almost any other disease. One of the other things that the roadmap emphasized, and again, this is just to make the case for all of you, that change in medicine, whether it's kidney disease or something else, is not just about diagnosis and therapy. It's much larger than that. So the roadmap focuses a lot on regulation and reimbursement because you can have the best idea, the best biology, the best drug or device, but if you don't have a pathway that allows it to get past the FDA, and if you don't have a pathway whereby somebody pays for it, insurance or government or a combination of the two, it's never going to get to the patients who are desperately waiting for these new therapies. And then the last thing I want to say about our roadmap for innovative renal replacement therapy is that if you look at the roadmap, and it's available on the web, it's basically a technical roadmap. But if you are a patient, this is a roadmap to freedom, which is going to take you from being stuck in a chair for in-center dialysis to being able to travel if you have portable hemodialysis, to being completely normal with an implantable kidney or with a regenerated kidney in the future. And this is a picture of a patient called Bill Peckham, who is rafting down the Grand Canyon using his portable dialysis machine. And, this can only, or is only available, I would say, for, let me get rid of, yeah. This is possible only for 0.000001% of our patients, but why can't more patients have the ability to do this? All right, so at this point, if you're listening to all of this, you would be perfectly justified in saying, Prabir, is this all pie in the sky? Is this too much too quickly? Do we actually have the science to do this? And the cartoon says, I'm a fiction writer in the grand proposal genre. I think that we actually have the ability to do this. And I'm just going to give you little snippets and snapshots of some of the stuff that I think is really exciting. So we now have a way of photo-oxidizing urea into nitrogen and carbon dioxide, which has actually been converted into something, into a dialysis machine, still not in humans yet, but close to it, that you can put into a rucksack and travel around with it. So portable or wearable dialysis may be a reality in the future. And then there is a group between Seattle and, between San Francisco and Nashville that have done a lot of work on creating an implantable bioengineered kidney. It's about the size of my fist. And within this kidney over here, they have layer upon layer of silicon nanomembranes for filtration. And they're actually working on coating these with renal tubular cells to reabsorb things. And the initial version of this sort of implantable bioengineered kidney has actually been placed in some pigs where it can actually result in some creatinine clearance. And there are group, and this is at a very early stage, but we're really excited about next generation graphene oxide membranes. And what I will tell you is that these membranes, which are really neat actually, could have the ability of allowing us to pull out a particular bad substance that we know we have to get rid of completely for patients to feel better. And they also have this huge surface area. So I've held one of these in my hand, and just about the half of my fingertip has a surface area of a football field, which is 2,000 times greater than the current membranes that we use. And then a huge amount of work in kidney organoids, which could not only be used to test drugs for kidney toxicity, but there's data which shows that flow in particular makes these organoids come together. So that could, of course, result in kidney regeneration or creation. And then lots of information, of course, about gene editing. I was at a meeting in San Francisco over the weekend, and the first patient, not the first, this picture shows the first patient that received a xenotransplant. He died actually after between 1 and 2 months because of cardiovascular issues. The kidney was working okay, but there's currently a patient that's 110 days out from a xenotransplant. And the reason for this big change is, and I'll speak about this because this is just amazing for me to look at these pictures, is that for all of my career, pig kidneys actually had these antigens, the GAL antigens that humans had preformed antibodies against. So every time we put a pig kidney into a human, it turned black, or into a primate. But now just look at these kidneys after 3 days, and now the patient living after 3 months. To me, that's just incredible. The FDA, at a more practical level, the FDA has agreed for 2 clinical trials, one of them with a kidney produced by a gene-edited kidney where CRISPR-Cas is used to edit out the bad genes, to edit out the alpha-gal proteins. So 2 clinical trials, one with an eGenesis kidney and the other one with a Revivicor, which is another company's kidney. And then I just want to come back again to policy before I go into my final slides. in 2019, a kidney executive order was signed, and it really sort of empowered the government to develop global payment systems for kidney care, where a group is formed and they're given a lump sum of money basically to care for a fixed number of patients with either advanced chronic kidney disease or end-stage kidney disease. There are lots of nuances as in any payment plan, but the bottom line is that the metrics are such that if you take care of patients well, you get a profit. You'll be able to make a profit. If you don't take care of patients well, if you don't meet the metrics, you'll actually lose money. But I believe that these sorts of global payment plans may be able to incentivize novel therapies. So let's suppose you want to develop a wearable dialysis device that actually reduces cardiovascular morbidity and hospital admission. So payment for this device may not be attractive in an eat what you kill fee-for-service model, but it could be really attractive in these global payment systems because the savings that you make from reducing hospital admissions would actually result in profit for the government and for your practice. So finally, just some messages for the future, 3 messages, I think. So the first is, it's really important to involve patients in innovation. And for me, that comes out of the work that we did with the Kidney Health Initiative. It comes out of the roadmap, which emphasized that whatever the future of dialysis or kidney replacement therapy is, it has to address the issues that are important to patients. And I'm going to show you a video which really, I think, makes the point about how important it is to involve patients in innovation. So let me, how do I need to get rid of the, okay, just give me, okay, I'm going to skip this in the interest of time. I'm having some problems. So let's just jump. So what I will say about this message is that it's really important to involve patients in innovation because the things that are important to patients are sometimes very different from the things that are important to physicians or insurers or payers. And we really need to develop therapies and devices that target the things that are important to patients. So that was a message there. Second message, if you want to go fast, go alone. If you want to go far, go together. That's an African proverb. And I will say that we want to go far with regard to the changes in kidney care. We want to be disruptive in our innovation, whether it's upstream, the first part of the slide of my talk, or whether it's downstream, which is the second part of my presentation. We need to have good outcomes at an affordable cost. We need to have equitable access. And in order to achieve this, we have to go together. Physicians, scientists, engineers, industry partners, federal agencies, and patients. The patient part, again, is very important because in a way, that has changed what I say to this slide. So initially, I used to end the slide over here. But what I've learned from patients is that there is an urgency to develop new therapies. And I remember a discussion with a patient where I was at a meeting and one presenter said, 41% 5-year survival for hemodialysis. We need to change this. The next presenter said, here's my bioartificial kidney. Isn't it great? I think in 15 years, we will be using this. And then a patient got up and said, I don't understand this. The first presenter said, I'm going to be dead in 5 years. The second presenter is really happy to develop something that's going to come out in 15 years. I will be dead in 15 years. Can you go faster? So I think there is an urgency. So I think we need to go together and go far, but I think we need to go fast as well. And then my last slide really emphasizes the point that it's always about people. And I know that Vandana likes this statement as well. But Margaret Mead said, never doubt that a small group of thoughtful, committed citizens can change the world. Indeed, it's the only thing that ever has. I think we need a lot of kidney champions. I think this is the right time for kidney champions. If you become a kidney champion at this point in time, I think you're going to have a huge effect as a catalyst. And again, the second most important thing perhaps from this presentation is if I can make all of you in some small way kidney champions. And then on that note of people, I've just been incredibly lucky to have learned from and to have worked with just a wonderful group of people. There are people on the ASN and the Kidney Health Initiative team. Vandana Nair from Emory, I think, has played a huge role in some of the things that we've done. The FDA has been a huge partner. I'm lucky to have some great people in the lab. And then this is an important slide when you talk about coming together. One of the nicest things about my career is that I have had the opportunity to work with all of these different types of people within and out with UNC in biomedical engineering, radiology, mathematics, chemistry, biomedical engineering again, chemical engineering, mechanical engineering, all the people in the ASN and the FDA. I think this has really been the fun part of my career, being able to interact with so many people. I'm grateful to my sources of funding. And finally, from the University of North Carolina, thank you to all of you for your attention. And with that, I'm going to stop sharing. I guess we've got just a few minutes. I was hoping to have more. Let me, how do I stop share? Okay, have I? Give me a moment. Okay, that should be it. Thank you again.
Thank you, Dr. Roy-Chaudhury. We're already getting multiple comments in the chat for truly an excellent talk. And I couldn't agree more with Dr. Manning, both inspiring and informative at the same time. What questions do we have from our audience?
So, Prabir, thank you very much. This is a great talk. And, you truly have inspired me to, who knew that I could become a kidney champion? But, my question to you would be, how do we get society excited about this? How do we get others excited about this? How do we get, payers and funders? And again, I totally agree with you. We can make we have an inflection point, and this is not just locally, this is globally. It's a global health issue. I mean, I come from Mexico, and kidney disease from diabetes is causing major problems in the population. How do we really, truly use something and something similar to what PEPFAR did for HIV to bring, diabetes, chronic kidney disease into the limelight?
Yeah, no. So again, obviously, thank you for that question. And, I don't have all the answers, obviously, but what I will say, I think I'm going to start off by saying that we have to have the right people, the passionate people, the creative people, the multidisciplinary people, the people from outside kidney disease that have new ideas and therapies involved. So that's number one. I think the second big thing is education and awareness. Just at a practical standpoint, now from a practical standpoint, now that we have these new therapies, we have to have, in my mind, universal screening for chronic kidney disease. We still don't have universal screening. And I understand that, there are guidelines for this, but I do think that the presence of new therapies allows us to change the paradigm. So I think that is one thing that we, as a community larger than the kidney world, need, I think, to focus on. And then the third thing, and I hope that Vandana and so many others and people at Emory and others will be partners with us, which is, and you mentioned this, we have to make the case about the value that nephrology and nephrologists and the kidney care community, I would go broader, that the CKM community brings to healthcare in this country and across the globe, brings to insurers and payers. And I think we have to, again, I think we need to get economists in, we need to get process of care people in, but we need to develop pathways. The American Society of Anesthesiology, for example, has developed some really great pathways whereby, what anesthesiologists do actually keep people out of hospital. And I would love, Dr. Del Rio, with your experience to get, I want you to be a kidney champion. That's the fourth thing that we need to do, to get people like you to become kidney champions.
We do have one more question in the chat. Many of the 4 therapies you mentioned can cause a transient increase in creatinine. How do we overcome the concerns of acute change in a lab value?
Yeah, so that's a really good point. And that speaks to this issue of no question at all, if you put all 4 therapies together, you will get a drop in your eGFR. The hope is that in the long term, by putting people, so if you're an advocate for putting therapies all on together at the same time, the advantage is that by doing that, you actually you could gain a year or a year and a half where you could have ongoing damage and kidney damage in certain patients, right? And so I think, number one, we need more education and awareness about these therapies. Number two, we need more data, good data, about what really happens, not just at 1 month, but at 1 year and 2 years, when you are aggressive, and you don't have to do it all together, but let's say you have an accelerated pathways to put patients onto these therapies because they have a lot of proteinuria, because they've had a bad slope in their eGFR going down within, say, 3 months. You need some data about what happens at 1 year, and do you actually get a benefit? So education, awareness, having the right data is important. And again, I think it's really important for this to be across multiple specialties, right? Because you don't want a nephrologist, starting the drug, the cardiologist stopping it. So I think this is another. I think we just need to work together. But no question at all, there will be a drop in eGFR. From a mechanistic standpoint, though, when you get a drop in eGFR, you get it because of reduced glomerular pressure. And in the long term, reduced glomerular pressure is good in preventing progressive kidney disease. At time. Okay. Yeah.
Thank you.
Happy to, please reach out to me. My email's out there. Happy to answer additional questions.
Where exactly is your email? Where exactly is your email?
Oh, here, let me put it in.
Thank you so much.
Yeah, I can put it into the chat.
Perfect.
Meeting here. It's prabir@email.unc.edu. There you go. All right.
Well, thank you again, Dr. Roy-Chaudhury, for this fantastic talk. Thanks everyone for being here. We hope you have a great rest of your afternoon, and we will see you next week.
Thank you very much. Superb talk. Thank you.
Thank you, Vandana. Take care all. My pleasure.